Hello students, welcome to your chemistry online class. As you know, we are continuing the same your first chapter of your chemistry book, and we have discussed in the last class about some properties of the periodic table. So let us see what we have discussed. We have discussed about your metallic character and their variation both in the group and in your period. We have also discussed about the chemical reactivity and their variations. There we have discussed about their boiling point, melting point, their physical states, and there was a task about to complete these questions. I hope everyone has tried. The answer we will discuss in your online Zoom meeting. Next, what is the, let us see. Today we are going to discuss about your ionization potential, electron affinity, and electron negativity. Okay, so let us see. First we will try to understand what is the meaning of ionization potential, electron affinity and electron affinity. That means what it says. Let us try to understand first. Then we will see what is given in your book. Okay, look at here students. There are your two atoms. Let me take here two atoms. That is one metal and another is non-metal. So we will take your sodium and the atomic number is 11 and the electronic configuration is 281, and sodium is having how many cells? 3 cells. Already one I have done. These are the other 2 cells. Next one, chlorine. Let us see. Chlorine atomic number is your 17. Chlorine is also is having 3 cells. The electronic configuration is 287. Okay. Just tell me, try to answer yourself about the atomic radius and nuclear charge. And I have told you for every properties you have to check these two terms. If these two terms you have understood and you got the answer on beyond on this, then you can easily write the variations along the period and down a group. On these two terms you have to be very clear. So see, in sodium there are total 11 electrons and in chlorine there are your 17 electrons, and your along a period the size decreases. How? See, here yes they are having 3 cells only, but you see here less electrons are there as compared to your chlorine. So here the the nucleus of your sodium is attracting the electrons. Here also the nucleus of chlorine is attracting the electron towards the nucleus, but as here more electrons are there, then nucleus will attract the more electron towards itself, and the nuclear charge is more. That's why the size it compress, and the size of chlorine will be less and the size of sodium will be more. Now let us try to understand what is your ionization potential. So let me erase you certain things here. See students, ionization potential means the energy required to remove the loosely bound electron from the atom. So your metals always ready to lose and non-metals always ready to gain. Why also that one? For getting stable And see, for ionization potential also we have to see these two terms, that is atomic radius and nuclear charge. And I have told you where is the atomic radius is more and where is the less. Here the atomic radius is more and here it is less. Why it is, I have told you, because here the nuclear charge is less and here the nuclear charge is more. We are comparing these two atoms only. Okay. So where the ionization potential will be more? Obviously here. In case of the chlorine atom, the ionization potential will be more, because in case of the chlorine atom, the atomic radius is less, means electrons are more closer to the nucleus, nuclear charge is more. That's why the ionization potential also will be more. That means more energy we have to put to remove the electrons. And here the electrons are not that much loosely bound as compared to the sodium. In sodium, with the less effort or less energy, we can remove the loosely bound electron. I hope everyone has understood ionization potential. If you have not understood, then see again this video, then you can understand. So let us see what is written in your book. So see here students, first we will see the definition of your ionization potential. The energy required to remove an electron from a neutral isolated gaseous atom and convert it into positively charged gaseous ion is called ionization potential. Yes, after removing the electron, it will convert into your cation, that is your positively charged ion. That is called your ionization energy or ionization potential. You can see one metal when it will be in the gaseous state and the ionization energy will be provided, then that electron will be removed and it will be a cation. Okay. So simply try to understand, ionization potential means it is the energy required to remove the electron, but that should be the loosely bound. If loosely bound, then less ionization energy is required. If completely, tightly bonded, if the electrons are more closer to the nucleus, then more ionization potential is required. Okay. So let us see your atomic size and nuclear charge, how it depends. The greater the atomic size, the lesser the force of attraction. Since the electrons of the outermost cell lie further away from the nucleus, they make their removal easier. That means what? Suppose this is one nucleus, one atom example I am taking here. If the atomic radius is more, then obviously the nuclear charge will be less. And if the radius is more, nuclear charge is less, then nucleus cannot, nucleus energy is, here it is less, it cannot attract the electrons, then easily the electron can be removed. That means less ionization potential is required. So now let us see nuclear charge. The greater the nuclear charge, greater is the attraction for the electrons of the outermost cell. That means what? If the nuclear charge is more means it must be the atom, it will be, size will be less, because nuclear charge is more, size is less means your atomic radius is less. Okay, atomic radius is less, atomic size is less, and your nuclear charge is more. And nuclear charge is more means obviously we have to put more energy to remove the electron. So ionization potential also will be more. Now let us see the variation of ionization potential. First we will discuss the variation of the elements down a group. So you see here the atomic size, it is increasing. As we moving down, the atomic size is increasing. Atomic size is increasing means atomic radius also it is increasing here, and nuclear charge is decreasing, and nuclear charge is less means the ionization potential also it is decreasing here. That means with the less energy, with the less effort also, here the electron can be removed. But here we need more energy. On the top we need more ionization potential to remove the loosely bound electron. As you can see, the atomic size is too less and atomic radius also less. Now let us see the variation of your ionization potential across a period. You can see here the atomic size is decreasing. Sorry dear students. Yeah, atomic size is decreasing. Atomic size is decreasing means atomic radius also it is decreasing. And what about the nuclear charge? Nuclear charge is increasing. Atomic radius is decreasing, nuclear charge is increasing. That means nucleus is having more power now to attract the electron towards itself, that is here. So we need more energy to remove the electron. That means we need the more ionization potential. Okay, so across a period your ionization potential increases as the atomic size is decreasing, and down a group your ionization potential is decreasing as your atomic size is increasing. So you can see the opposite here. Okay, like this way also you can remember, but the thing is not to remember, you should understand, then only you can write the variations. Here you can see the exact value of ionization potential it is given. You see lithium 1 520, beryllium 899, like this way it is increasing. It is increasing up to 2080. This is across a period. Just now we have discussed across a period ionization potential increases. So here you can see the the value also it is increasing. This is second period and this is third period it is given. Then down a group you can see, down a group it is decreasing. See first one, hydrogen 1 it is 1312, whereas cesium 1 your 375, fluorine 1 1681, whereas iodine 1 your 1008. So down a group your ionization potential is decreasing. Now let us see what is your electron affinity. Electron affinity is the amount of energy released while converting a neutral gaseous atom into a negatively charged ion. So simply ionization potential means here the atom it is converting into your positive ion, whereas in the electron affinity the atom is converting into your negative ion. When your atom can convert into your negative ion, when there will be the gain of electrons, and you know metals never gain the electrons, they always lose, and non-metals they always gain the electron. So obviously the electron affinity of the metals it will be less and non-metals it will be more. And you know the variation of ionization potential, then easily you can write electron affinity also. But we will see thoroughly on the basis of terms, the two terms I have told you. Always remember, for any variation you should know atomic radius and your nuclear charge. So let us see. So see here, this is one atom and this is another atom. Sorry, let me draw here. Okay, now let us try to understand atomic size. Here you can see the atomic size is less, here the atomic size is more. When the atomic size will be smaller, the electron affinity will be your greater. Why? When your atomic size will be less, then your ionization potential is more. More energy required to remove. The same way, electron affinity means what? The amount of energy released. So here, when this atom will convert into your negative ion, at that time it will release more energy. As ionization potential is, in ionization potential we are putting more energy. So obviously while converting into negative ion, more energy it was there, so more energy will be released. But you see, in case of this atom, here the ionization potential, it was less. Yes or no? Big atom, means atomic size is more, means less energy is required to remove the loosely bound electron, less ionization potential is released, so less energy is there. So when this one will convert into your negative ion, so less amount of energy will be released, that is the electron affinity will be your lesser. Ultimately, let us see your nuclear charge one. Here the nuclear charge is more, here the nuclear charge is less. So as the greater the nuclear charge, and obviously greater in the electron affinity. Less in the nuclear charge, there will be the less in your electron affinity. I hope you have understood. If you have not understood, see the video once again and try to understand. Then also, if you are unable to understand, then you can ask me in the Zoom meeting. Next one, let us see, their variation, let us see. In a period from left to right horizontal row of the periodic table, the atomic size decreases and the nuclear charge increases, so the electron affinity here increases. That means what you see, look at here, your left to right, that is across a period, the atomic size decreases, you know. Here the atomic size is decreasing, atomic radius also it is decreasing, and nuclear charge is increasing. As the nuclear charge is increasing, means more energy is there, then obviously while converting, the same amount will be released. Same amount of energy means more energy will be your release. That means your electron affinity also it increases across a period. Now let us see the variation of your Downer group. Your Downer group, you know, the size is increasing. Atomic size is increasing, atomic radius is increasing, nuclear charge is decreasing, that means electron affinity also decreasing. That means what? Less energy is there in that atom, so obviously less energy will be released. Okay, next one, if you will read thoroughly whatever written in your book, then you can understand, and if you will see this video also. Now let us see what is your electronegativity. Okay, so see, let us see some example. This is your sodium chloride. In sodium chloride, sodium atom is there, sodium cation is there, and chlorine anion is there. Here clearly you can see one is completely positive and another is completely negative. But you see another example, if you will see CCl4. Here this is a covalent compound, both are non-metals. Okay, this is carbon and this is chlorine. So here no, Both are non-metals. That's why they share the electron and they form the covalent bond. But do you remember you have seen, you have read one example of your HCl. This one sometimes it is your ionic compound and sometimes covalent compound, but maximum time we are writing it as covalent compound. But your hydrogen, it is sometimes it is showing its character similar to your alkali metals and similar to sometimes with your halogens. So we can write this as H plus Cl minus. That means what? The H is not completely metal here. Okay, so H is having this del plus and this one del minus, means slightly positive, slightly negative. So suppose one electron is there, then out of this hydrogen and chlorine, which one will be able to attract this electron towards itself? As here the chlorine one, it is the non-metal. This is having the more electrons. So obviously chlorine will attract this electron towards itself. This is only your electron negativity. Electron negativity means to attract the shared pair of electron towards itself. So obviously that electronegativity, it will be more in case of the non-metals, as the non-metals are having more electrons. They are having the more power of gaining electrons. So easily they can attract the electrons. So the electronegativity, the metals will have less electronegativity, whereas the non-metals will have the more electronegativity. And you know your atomic size, it decreases across a period. So what will happen here? Electronegativity, your electronegativity, it will increase across a period, because you know the left side is completely your metals and right side is your completely non-metal. So let us see what is given in your book. Look at here, students. The tendency of an atom in a molecule to attract the shared pair of electrons towards itself is called your electronegativity. So some electronegativity values it is given, you see. Both your across a period and down a group, both are given, you see. This is your across a period and this is your down a group. You can see their values. Lithium is having 1.0, that is 1, whereas your fluorine 1, it is 4, that means it is increasing. And down 1 you see, lithium 1, and whereas cesium 1, 0.7, that means it is decreasing. I have told you just now, your electronegativity, it increases across a period and decreases down a group. On the basis, so there is a task on the basis of atomic size and nuclear charge, how it affects or how it depends the electronegativity, you have to read your own. If you are having any doubt, then you will ask me in your next class, the Zoom meeting. Okay, only the variation I will tell you now. So across a period, the electronegativity increases from left to right, just now said, and down a group it decreases. Then you see, one point is there to remember, inert gas are having 0 electron affinity because they are completely stable. They cannot convert into any anion as they are stable. That's why your group 2 and group 15, they don't have any negative values. Okay, this is the exception you have to remember. Okay, the remaining we are going to read in your next class. I think you cannot understand if you'll see this video only once. Try to read, try to see 2 times. After that, read this PDF. I think maximum you don't have the book, so you see the PDF which is there in your group. Then also if you are having any doubt, then you can ask me. So I think you have noticed one thing. Your across a period and down a group. First across a period. We have seen here your across a period, the ionization potential also increasing, electron affinity also increasing, and your electron negativity also increasing. The same down a group also, here ionization potential is decreasing, electron affinity is decreasing, and your electron negativity is decreasing. So if you will remember any one, ultimately the two also you are remembering automatically. Okay, so remember the variation of ionization potential, electron affinity and electron negativity, it is same. Okay, I hope today's class it is helpful. Thank you.